So welcome everyone to day 3 of the ESIP January meeting. My name is Annie Burgess. I'm ESIP's lab director, and I'm just so pleased to see so many familiar names in the participant list. It's always heartwarming to see that, but even more excited are the names that I don't recognize. And I hope that you come away from today with a reason to become engaged more with ESIP and with the ESIP lab. And really, I was reflecting this morning how it's already been an exciting few days with so much stellar content contributed by you, the ESIP community. So let's go to the next slide. So with that, this is something I did at the July meeting last year that I just wanted to start off by reflecting on a few highlights, I think, of our first 2 days. So let's do a bit of a recap. So my first highlight is I'd like to give a big round of applause for all those session leads who really leaned into session design. It showed and was appreciated for those, it showed and was appreciated. For those of you who have only attended and never led a session, ESIP brings in Master Session Design Professional Charlie Haley to work with any session chair who so chooses to create an engaging, fresh session idea. And we do this for both virtual and in-person meetings. Kudos to Megan, ESIP's community director, for the communication and management of getting this training to our community. For Charlie, who works with our session leads, and to the session chairs, whose efforts in this space are noticed and appreciated by all of us who attended these sessions. My next highlight is Susan's opening remarks. If you missed our executive director, Susan Shingledecker's opening remarks, you should really catch them when we release the recordings after the meeting. It was Susan's message that she is approaching this year's theme around data ethics with a thirst for knowledge, because admittedly, she doesn't feel like an expert in this space. We often assume that we learn at a meeting, or we learn the most at a meeting where the person who kicks it off purports to have all the answers, all of the knowledge around a topic. But I think having humility to show up and say that you don't know opens the door to collaboration and learning much quicker. I mean, who wants to start a conversation with someone who claims to know it all? To quote my niece, who's a senior at UC Berkeley, who, when asked kind of what trait she most appreciates in a good professor, she replied back enthusiastically to me, humility. I like a professor who's honest about what they know and what they don't. And I think Susan's opening message really resonated with me in that space of sharing what you know and what you don't know, and often saying what you don't know really opens the door to community and collaboration. Lastly, I'd like to highlight the research showcase yesterday. There were so many wonderful posters and enthusiastic conversations happening, but it was really, to me, the content that a lot of students provided that stuck out. I was kind of gobsmacked, as were some of my colleagues, with the level of sophistication and insight that these students provided. And I would recommend that all of you, during the rest of our time together, still go check out the research showcase. That space is still open. The links won't be live. You can't join a Zoom room with the presenter, but the content is there and it's really stellar. So please do go check it out at some point. So with that, I'd like to tell you a bit about a program within ESIP that we call the ESIP Lab. The mission of the lab is to facilitate learning opportunities for earth scientists and data professionals to increase their technical savvy while expanding the collective skill set of our community and knowledge of earth system science. We work towards this mission in several areas. First, our annual ESIP Lab request for proposals focus on priority areas within our community. However, I'd say our RFP process stands out because we ask investigators to not only share scientific or technical objectives, but also share a learning goal during their project. For example, one of this year's funded projects, who you'll hear from shortly, stated they want to identify best practices for using GitHub Actions and workflows. By encouraging investigators to tell us what they don't know or what they don't know how to do, it creates a learning-focused environment that encourages collaboration and removes any sense of shame in not knowing how to do all things. Another component of the lab is facilitating broad technical inquiry. One particular example of this has included supporting numerous individuals across NASA, NOAA, USGS, and other agencies and institutions with data management and analysis in the cloud through access to ESIP's commercial cloud resources and by working together in our instance of the Nabari data science platform. So I'm happy to share this list of our current cohort of lab RFP recipients. The 2023 RFP theme was water and wildfire. We'll soon be working on what our 2024 theme will be, and I encourage you to add potential themes to the chat. As someone who lives in Montana, I feel the issues of water and wildfire are ever present, but this group has really expanded my consciousness about the facets in water and wildfire I had truly never considered. This morning, you'll be hearing from each of these projects. These projects have very recently wrapped up or are soon to finish their official development through the ESIP lab, but each of these projects are ongoing. So I encourage you to engage with the speakers through chat, and please to post your questions to Slido, and hopefully we'll have some chance to engage with the speakers throughout their presentations and throughout this whole morning session. So with that, the order of the speakers, we'll have Mike Johnson from Linker, we'll have Sonia from UC Davis, Raphael from Carbon Plan, Jesse from EPIC, Shahab from the Alabama Water Institute, and Liz Ferguson from Ocean Science Analytics. With that, I'll ask Mike to get ready to share your screen, and we'll get going.
Cool. Thanks, Annie. Right, I think practice paid off and got the slide. Awesome. Yeah, so really appreciate the opportunity to come and talk about our project a bit. Rachel was down in New Zealand visiting with one of our partner branches there, so I get the opportunity to present for us today. And the topic that we really want to discuss is how we tried to expedite some of the processes or the problems with increasing environmental data access. So the value proposition that we wanted to start with was that we're aiming to help Earth system scientists at large more easily discover and access geospatial data for areas of interest. And we all know this is kind of important because data is critical to science. It's critical to science that we do at Linker, it's critical to science we do at NOAA, and it's critical to research and development across universities and a lot of federal agencies. And the core that we kind of identified is that we have thousands of diverse data sets. They might be multidimensional, single band image files that are hard to find and manage. And we have a core set of community tools with thousands of ways of tackling the same problem generally. And this ends up wasting a lot of time that went into not only the data creation, but also the researchers' time in executing repetitive tasks. Our motivation for the project was how do we streamline some of these challenges about data discoverability and access. And we came up with 3 goals we wanted to have. One of them was to create a central federated updating source of data that's available. So instead of having data out in the wild, there's a location where you can find what's available with some concrete metadata. We wanted to have some language agnostic access patterns built around a set of concrete metadata. And we wanted language-based implementations for getting data subsets programmatically. So the project outcomes that we had, there were 7 that I think are unique to our project and that we're pretty proud of. And one is that we have an automated catalog pipeline. So this is that GitHub action that Annie had mentioned. That was one of our learning objectives. And this runs monthly with robust error reporting through GitHub Actions to figure out where data lives and if it's still available. And it produces the metadata we need for some of the tools. We had a rewrite of an existing R package that made it more general and extensible, and we have a Python implementation of that same logic. In addition to this, we really made some strong efforts to have broad outreach and collaboration, which we'll talk about at the end. We have full documentation and an example website. We were able to attend 2 ESIP conferences based off the generosity of ESIP. And we really were intentional about trying to onboard some of our early career scientists to Linker, and giving them ownership, authorship, and shared responsibility, and making sure that these were successful in the end. So to dive into the first three, just kind of what were the concrete deliverables, we have that automatic extended catalog. So each month, GitHub Action goes and runs, it scans 33,400 different resources that hold over 100,000 different assets, and it reduces it to a single catalog and schema. We have some error reporting that tells us if a resource is no longer available or if something has changed. We can make sure that these are still all accessible within the software that relies on this catalog. This catalog is then generated as a Parquet file that can be hit from a URL. The two software implementations, the R and the Python repositories, we've done our best to make sure that the API and the logic looks the same. So whether you have R code on the left there or Python code on the right, you'll see that they try to be very consistent in the way that they're saying, here's an area I'm interested in, here's a data set I'm interested in, and go and please access that data for quick work. And so here we're getting some data from TerraClime about maximum temperature and precipitation. We reduce them to monthly means. We get some DEM data, we get some soil data, and all of these are accessible and then ready to work with within your environment. The outreach and collaboration was something I thought ESIP Lab was really encouraging of, and we were really excited about, and we wanted to copy or comment on a few of the successes I think that we had with this project. The first one was with NOAA's Office of Water Prediction. So while Linker is my home, most of my time is actually working with Office of Water Prediction, and this federated data catalog and these processes are part of what they're calling their enterprise geospatial efforts, all related around the next generation national water model. So that fifth element over there really builds on this catalog and has tried to extend some of the utilities for that system. One of the big successes we had with it was reducing something that we used to run in Google Earth Engine to running within a Climate R environment. And we were able to do something that took weeks and batch processing on Google Earth Engine, reduced it to less than an hour on a GFE laptop. If you know what GFE means, you'll know that that can be a challenge at times. But this allowed us to summarize 20 years of data over 9 different variables of a 4-kilometer grid to 880,000 polygons that are used for the next gen system. We're also helping a NASA project that the Linker has. It's led by Keith Jennings. It's called Mountain Rain or Snow. It's a community science project that people report if there's precipitation falling. Is it snow or is it rain? And it helps them try to better understand the phase shifts. And both the precipitation data that Climate R is allowing, as well as the EM data, has helped them record and make better sense of the information that they're getting from these local respondents. We work with the USGS National Hydrologic Geofabric team as well. Rich McDonald has built an awesome tool called GDP Tools. Does a lot of area weight averaging and things like that and data access for their project specific to WMA. And part of this catalog has made it into that core data set. And Rich is awesome to work with, and it was a really great collaboration that kind of was stemmed from this proposal. And then another cool thing that we're pretty excited about is we were reached out from the team that writes the geocomputation with R, and in the next release that's coming out, I think in February or March, Climate R will be part of their data access within our use cases. So we're pretty excited that it made its way into there. We did our best to kind of advertise and show the ESIP or the great advantage that ESIP has given us within this. We were able to attend 2 conferences, which was awesome to meet everybody in person. It's great to be here today. Get to share a little bit more about this and learn from all of the other talks. And it was something we were really excited about that came out of this. And so we were asked to kind of give 3 key points at the end. And I think it's knowing where data lives and aligning disparate data access patterns can streamline data discoverability and use. And asking just for the data you need rather than the complete data sets can allow workflows on personal computers to become more performant than large-scale systems like Google Earth Engine. And being part of a larger community is the best way to learn, grow, and share. And that's something that I think was the biggest takeaway from this proposal project at large. And for that, we really want to thank ESIP Labs. If you have any questions or want to contribute to anything of that nature, please feel free to reach out.
Thanks so much, Mike. So I encourage all of you to nice reactions, especially from our fellow lab cohort, to ask any questions that you may have for Mike. We have a couple minutes, so I'll jump in and say, how does this relate to Stack, Mike? And that's from Rich Signal.
Yeah, awesome. That is our future work. Right now with these 100,000 some assets, discovering data within the catalog is one element we want to work on, but then also how do you integrate this and point this at a Stack catalog to apply the same spatial temporal subsetting and then use all those URLs that come out of a Stack catalog or Stack assets to kind of implement these same workflows. I think with our Stack and some of the tools that have already come before us, I think that integration should be easier than it would have ever been just a few months ago.
Thanks, Mike. And we have time for one more. Dave, do you want to go ahead and go off mute? Actually, we might not be able to. I don't think participants can go off mute. Dave, could you put your question in the chat? But in the meantime, let's see. Yes, Dave is, but I'll say first we have one from Steve. Do you find anyone anyone working on ice storm accumulation?
Who I have not run across that one yet. We've had some interesting use case about rivers freezing up and flooding impacts, but nothing about unless that's what you mean by ice storm accumulation. But maybe I'll leave it at that.
Thanks. Thanks so much, Mike. So from Dave, Mike, can this approach be applied to identifying working web services that can serve decision makers?
Identifying, so we usually we've kind of gone to core groups like USGS, NOAA, NASA, some universities that have large servers, and those are the primary ones we hit. We have GitHub issue templates that people can say, hey, this is a data set I'm interested in. And if it's in a common platform, like a web feature service or open app catalog or a FTP of TIFFs, whatever it might be, usually that can get integrated pretty quickly. And that team I mentioned is at the beginning is pretty eager about adding those as those issues come in. So ideally, if a web service is identified and it's open, it could be added to this, and then those checks would make sure it's still up and available.
Great. Thanks so much, Mike. Okay,
Dave,
so
I'll try to make it.
oh, sorry.
Oh, I was gonna say, Dave added, please. I'll try to make that session at 1:30. Yeah, thanks, Dave.
Oh, great. Great. Thanks so much. Sonia.
All right. Hello, everyone. Let me share my screen. And go into slideshow. Okay, so I'm going to be presenting on a project that I worked on with John Kim and Alex Dye, as well as my advisor, Chata Pau. It's prototyping an image-based coastal fog detection network using camera locations along the Oregon coast. And in the background is a photo from one of those locations. So our value proposition is that an image-based coastal fog detection network will enable the research community to understand fine-scale spatial patterns of coastal fog prevalence with a downloadable database and web application. So the inspiration for this project is that coastal fog is an important water resource and also temperature moderator along the Pacific coast. I'm in Davis, California, where summers are typically over 100 degrees. And if you go to San Francisco, the climate is completely different. And coastal fog is an important part of those climate differences. And because of this, there's a lot of concern about how coastal fog patterns have been changing or might change in the future. But it's tricky because the spatial variation of coastal fog is not well understood. And one of those reasons is because there isn't a comprehensive database of spatial variation of coastal fog. And so this is the widely known problem. And existing data sets of coastal fog from satellites have limitations. For example, MODIS has a low temporal resolution and its flyover time is 10:30 a.m. for California, which is an hour when fog starts to burn off. Goes west, which has a half-hour temporal resolution of coastal fog, which is great. However, it can't distinguish between fog and low cloud cover. It's only going to pick up the highest level of clouds, and low cloud and fog have very different implications on water resources. And so why might cameras be a good candidate to detect coastal fog? And so one of the reasons is that it's existing infrastructure. For example, surfline.com, where the images that we're using for the prototype come from, they have cameras facing beaches across the Pacific coast and across the world. And then the Department of Transportation, for example, Oregon and California, have cameras along coastal highways with publicly available data. And cameras are also relatively more affordable than existing methods of detecting fog, although that comes at a lower accuracy compared to like optical depth sensors or that measure visibility. So our methodology was to label over 8,000 photos from 6 different sites, either foggy or not foggy, and then develop different classification models using fog-aware image characteristics that were previously defined in the literature, and then apply this to a database of 2022 and 2023 summertime images at these 6 test sites, and then compare how the predicted fog measurements are to airport weather data, which have visibility measurements. And so those are marked with an X on the map, whereas the camera locations are with the circle. And particularly if you look around Newport, Oregon, there's 3 cameras that are all co-located and within 10 miles of an airport. So that is a good opportunity to look at how does the predicted fog presence vary for within a close location. And so our learning objectives along the way were to learn how to implement deep learning models in Python, and then also create interactive data explorations. And so neither of these were the tools that we had originally proposed, but these tools both fill the same purposes. And so this is a typical Keras visualization of the model that I will show on the next slide. And then another, we use Streamlit for interactive web application. And so this is just an example of the Streamlit documentation, but putting in a few of these sites along the Oregon coast. So these are the results of the 3 kind of best performing classification models, convolutional neural network, a random forest, and logistic regression. And they all had pretty comparable metrics for how well they were able to identify fog. And they all did a decent job of getting the variation in fog occurrence per site. Although they all do have similar biases. For example, the X is the labeled data, and all of the models will typically be higher versus the labels kind of being in the middle. And this code is on GitHub repo right there. And for outreach and collaboration, we want to make a database with these publicly available through the Streamlit application. And so this is just to be deployed in the coming weeks. This is right now the top of the application, where you can choose a site in which models you want to look at, and then compare it to the closest airport weather data for whatever date range you pick. And then this site will also have the database available for download. And so our key takeaways are to understand how coastal fog patterns are changing. We first need to characterize what is the spatial variation. Cameras that show red, green, blue provide a valuable opportunity to study coastal fog spatial variability. And several classification methods provide reasonable detection of fog and camera images, which can be used in future analysis and deployed on more cameras. So thank you for listening. Thank you to ESIP Lab for the support and Surfline for allowing us to use their images.
Great. Thank you so much, Sonia. Fun fact, during a meeting a couple months ago, Sonia had said she had, you said 8,000 images, but I'm almost positive that you said you had personally classified 10,000 foggy images, which kind of makes me draw parallels to the early GIS days when people's whole careers were digitizing things, that if we're now in a new era of annual work of image classification. So I've got a couple, we've got time for a few questions. So remember, you can add your questions. Oh, thanks so much to my ESIP team for putting that link in chat. So we've got two questions. The first one is, who do you see as the users of coastal fog data? Who would be using that application that you showed us in your last, second to last slide?
So there's the Pacific Coast Fog Monitoring Project. And so the group is no longer an official USGS group. However, a lot of its members are still very interested in fog, spatial patterns of coastal fog. For example, the people who have goes west algorithm for detecting fog and low cloud cover, as well as the camera detection also has a public safety aspect, especially along highways and for traffic, because fog and driving, as we know, is not a good combination. So that's who we see using it. One, people interested in comparing it to satellite measurements, and then also for people in the transportation industry.
All right, and then one more. Would data from residential solar panels be a good way to identify fog?
That's a great question. I'm not sure what that data looks like, so I'm not sure how sensitive it is to cloud cover versus ground lying fog. But that's definitely something to look into.
Great. Thank you so much, Sonia. That was excellent. And one more plug that Sonia won outstanding student paper competition with this work a few months back. So just another kudos to her in this really excellent work that she has taken on. All right. So next up, we have got, I believe it's Raphael. Raphael, are you ready to share your slides? All
Can
right.
everyone hear me and see?
We sure
slides?
can. Yep.
Wonderful.
Go ahead whenever you're ready.
Great, thanks. Hi, everyone. Thanks for coming. My name is Raphael Hagen. I work as a data engineer for Carbon Plan. And today I'm going to talk about real-time visualization of satellite-derived active fire data. So quick background, I work for a nonprofit called Carbon Plan. We aim to ensure scientific integrity and transparency of climate solutions through open data and tools. One of our research interests at Carbon Plan is forest offset projects. These are like carbon market tools, which have the goal, at least, of changing forest management practices, stopping logging, or doing some other thing to forests to hopefully get offsets for these so that someone else can buy credits for these and emit more CO2. Whatever you think of offset projects, they are vulnerable, at least forest ones, to wildfires. In 2020 and 2021, we saw a lot of massive fires throughout the Western US. And a lot of these fires, it turned out, burned forest offset projects. This picture right now is a satellite image of the Bootleg Fire Complex, a fire of almost 400,000 acres burning up a large offset forest. In 2021, we built a web tool to monitor forest fires and offset projects. This is an archived version for the 2021 fire season. There's a bit here, so I'll try to walk you through it a bit. On the left, you can see a bunch of different offset projects labeled here, ACR 255, etc. And then on the map, we can pan around. We're currently in Northern California. These red polygons represent official fire boundaries by the National Interagency Fire Center. So these are the official polygons that the NIFC updates with on-the-ground measurements. So they're quite slow to update. In addition, we also have these gray polygons. These gray polygons are offset forest projects. So if we go back up to where that images I just showed you earlier, we can see the bootleg fire complex. And you can see below it, this gray area for ACR 273, a really big offset project. And you can see it burned up an incredible amount of this offset project. So this tool was really great in helping us track a lot of the fires in the 2021 fire season, but the perimeters were really slow to update. So we couldn't really see in real time what was happening with the fires. So through the help of ESIP, we wanted to change that and get near real-time fire data for future tools. We were able to do this because of a NASA program called FIRMS. This is a great program that takes data from multiple satellites, MODIS, VIIRS, Landsat, etc., and shows like heat anomaly detection across the world. So on their map right here, you can see these red spots as potential fires. So FIRMS provides a web map, which is nice, but it also provides an API, so you can go and get the data you want. However, a lot of the data at the FIRMS API wasn't really in the data format that we needed for web mapping. So we decided to build an open source Python pipeline to grab those data. This is all open source and the data is all free to use if anybody has any use for it. This pipeline has a few steps. First, we had to figure out how to interact with the NASA API to grab the data for VIIRS and MODIS. Once we had that, we wanted to subset the US and Alaska. And then we wanted to filter out any low confidence values. So we weren't seeing just kind of heat anomalies. Once we had that, we had a bit of a branch. First, we wanted to generate GeoParquet files. These are cloud optimized data formats that are really good for analysis. But we also wanted to create vector tiles for really performant web mapping at multiple zoom levels. In addition to that, we wanted this all to run automatically. We didn't want someone to, oh, I forgot to run the pipeline. So we set it up with GitHub Actions. This means that every 6 hours, I believe, our data pipeline would run, go grab the data, and automatically update our web map so we could see how the fires were changing. In addition to the open source pipeline, we also created some tutorials about how to use this data and how to use our utilities. This QR code should lead you to the GitHub page with the tutorial. Once we had all that data coming up automatically every 6 hours, we could add that near real-time data to our web map. This is our updated web map for 2023. As we all know, it's December, so there's not that many wildfires. But we can see the 2023 fire outlines. These red polygons again are the official polygons from the National Interagency Fire Center. But as fires were going on, we could see these orange dots as near real-time detections from NASA MODIS. It's not a great example here, but in some of the fires this summer, we could see the fire fronts changing. As you could see the official polygons, you could see the fronts from the fires as new data was coming in. Going back to think about how this all worked, we had a few lessons learned. Initially, we were going to use ZAR, a cloud-native data format, but we ended up using this strange vector library called protobuf to make these multiple zoom layer levels. Also, it took a bit of playing around to best, like how to figure out how to best represent active fire fronts in web mapping. Because we'd create a few days of fire data, we wanted to show the actively burning fronts. Now that we have all this data and automatic pipeline, we're really excited to apply it for the 2024 fire season. We should be all set up to go. So then when fires start to break out and potentially affect offset projects, we'll be able to see them. We also hope that this tool and this is all open source and public, and the data will be used by scientists and journalists. We worked with the Oregon Public Broadcaster to cover the bootleg fire and how it affected some of these offset projects. So we hope this near real-time updates to this tool will make this work even easier. Just want to give a thanks to ESIP Lab for sponsoring this project. It's really helpful. If you have any questions, please contact us at hello@carbonplan.org. In addition, I just want to plug the 4 p.m. Eastern Cloud Native Plenary Sesh. I'm giving a talk there, and there'll be a lot of sessions on how to use cloud native data. Thanks so much.
Thanks so much, Raphael. That was great. And we have time for a quick question. And thankfully, Pierre has already put one in chat. So I'm guessing a few people want to know, what made you opt not to use ZAR? Performance?
It had to do with like rendering like fire or not fire pixel data, like raster data at these high zoom levels. So end up using like vector data to represent the outlines of the fires, worked a little better. This kind of was in the more like, how did it look on the web, not really ZAR's performance. So that's why we also, I think, opted for another cloud native format, such as GeoParquet. But we could use ZAR for that as well.
Great. Thanks, Raphael. And yeah, after your talk, if you want to put some links to those different libraries in chat, I'm sure some folks would be interested. One more quick question. Did you try using active KML file from firms to represent live data updates, the live firms data updates?
Yeah, I believe we wanted to use KML. I don't think would work very well with our kind of web-based visualization. As far as I understand it, could be wrong here, but KML is more like point data. So we're trying to represent like vectors of fire outlines. Okay,
great. Thanks. And again, feel free to jump in. Raphael will be keeping an eye on chat. So if you'd like to engage further, we'd love to see the conversation keep going. But with that, great job. And up next, we have Jesse from Epic. Jesse, are you ready to share your screen?
Yep. Okay. Can y'all hear me?
We can hear you and we can see you. Everything looks great. Go for it.
Okay. We are going to take a hard turn. This is not going to be that technical of a talk, but I'm really excited to share the work that I've been doing in collaboration with the Center for Geospatial Solutions and Oregon Water Futures to advance drinking water justice. And so the main thing that we've been working on is how to make it as easy as possible to know if your drinking water is safe to drink or not. This has to do with a lot of data wrangling. And so the map here on the left-hand side is showing which states make that easy right now. And then all of that orange and red is where it is basically impossible to figure it out. And so we, in prior work, we're collating that information. And then this phase of the work was making it as easy as possible to understand for utilities that might have that data to create and maintain it. And then one of the things that we learned in doing so is that sometimes that data is a little bit off and we need to validate that with community members. This data is really useful not only for community members to know if their water is safe to drink or not, but also improving the design and implementation of a number of climate and water programs, whether it's knowing who is benefiting from infrastructure investment improvements, drought resilience and supply relative to population demand, and then overall recreation as well. So we're going to talk about two interrelated projects to answer that question. So the first is a bit more on the technical side, which is creating the data for water utilities. So in the United States, there are roughly 50,000 community water systems, and more than 60% of those community water systems do not have geospatial data that is the boundary of where they serve in any kind of publicly accessible or national data set. But we know that whether or not they have that geospatial boundary, they have a list of addresses that they build to. So we wanted to say, how can we take that address list and turn it into a boundary without them needing any GIS experience, in automatically syncing that up to the national data set. So the way that we went about doing that was we created a workflow that basically is relatively simple to, but had a pretty large impact in being able to take that file, the billing roster, or right now there's a lot of work on lead service line inventories work. So if they had that Excel files, we then matched it. We imported the addresses, we matched it to parcel data, and then created buffers around that to unify the disparate geometries to create a uniform boundary. What that means is there's a lot of different times where maybe the address over here and it's a cul-de-sac and there's another part of the community here. So we still needed to unify all of it into one. And then we both provided that shapefile back to the water utility and published it within our overall national data set. The second thing that we've been focused on, as I mentioned, is that we heard anecdotally that where this data was created in those 17 states that I showed you before, that it would sometimes misrepresent tribal or minority communities' access to water. So the boundary would show, yes, we provide drinking water to them, but you talk to the tribe and they say, we actually do not get drinking water from that water system. So we partnered with a community group based out of Oregon, which is actually a conglomerate of about 8 different community-based organizations that do a lot of work in advancing drinking water justice to start validating whether or not what the boundary showed was in fact reality. And the main aspects there, again, is to try to say, is that accurate? And when it is an accurate representation of who gets drinking water from who, and they're safe drinking water, we also want to be building trust with those community members that their water is safe to drink or not, and then take action when that is not the case. So the first thing that we did is just a lot of community-based conversations and data evaluations on where to hone in. So we were both looking at the information to say, here's where we have an understanding of where the boundary is at, match that to drinking water quality violations, and then saying, where does that overlap with communities that have people of color that are, there's more than 50% people of color in that community, or where it shows that they serve a federally recognized or unrecognized tribe. That kind of created our nexus of where are we going to do conversations. Step 2, it's just a lot of emails and phone calls and being able to, and also in-person events to go into those communities to say, here's what the data shows. And then can we validate this, yes or no? The thing that now we're reconciling on the data side is how do you hold both the authoritative data with the accurate data, and where can we have a reconciliation process with the utilities or the state agencies that manage that information, and then where can we have a uniform understanding of who's getting drinking water from who. And so kind of in closing here, some of the learning objectives that we've had along the way, and something that maybe many folks have heard, but it's just to go slow to go fast. So a lot of, this was a 9-month project over the course of last year, but creating those community relationships took the better part of 4 to 5 months to get to a place where we could start doing the outreach and engagement with folks. The second thing, which I didn't go too much in the details on that first project, but it was actually, we found what are the quickest ways to do that parcel matching. Where are there packages that already exist? We didn't actually have to create too many new workflows or create too many new tools, but just kind of link together a couple different workflows that made it relatively quick and simple to build the tool. The main outputs of this project was creating these tools creating the partnerships, collaborations with Center for Geospatial Solutions and Oregon Water Futures. And then one other things that I just wanted to add that was a big bonus made possible by this project and being able to invest so much time and energy in reconciling data across federal, state, local, nonprofits, tech providers is that coming up in about 2 weeks now, we're going to be hosting a workshop with roughly 60 folks across federal agencies, nonprofits, and tech providers to say, how do we reconcile this? How are we going to maintain this data going forward? How are we going to unify that information? And then what level of accuracy do we need to inform different types of decision making around safe access to drinking water? And then just to close on some of the, I guess, takeaways of this project, we first wanted to just make it as easy as possible for folks to input the information. So if a water utility doesn't have the GIS background, then what do they have? Great, let's make a tool from that. The second was just the amount of outreach and engagement that we did throughout this work, which is, not only who has the data, but who's impacted by the data and who in the long run is going to be responsible for maintaining it. So that trio of folks was kind of that broader stakeholder group that we were working with. And then lastly, just validating what we're seeing. And I think along the lines of this theme of data ethics, right? This might be authoritative, but it's actually wrong. And so spending the time with community members to make sure that it's accurate and then being able to use that confidently in policy and decision making. And so with that, I will just say thank you to ESIB and the number of collaborators that we had throughout this project. Feel free to reach out at any point.
All right, great. Thanks so much, Jesse. That was really excellent. And I'm guessing if there's a tool right now that we put in chat that
Yes.
put in your address and you could see where your water comes from, all sorts of people would be hopping on that. And I know that what you're creating is going to be much more impactful than something fun to do at a virtual meeting. And this is just really impressive work. So again, any questions can be added to Jesse in chat or in Slido. We do have one Slido question. I'm guessing that says, do you know any other federal agencies or organizations that are working on this issue? I'm guessing specifically the where's my water coming from?
Yes, so we have a pretty robust network of federal agencies that are working on this, primarily EPA. We've worked a lot with the Office of Groundwater and Drinking Water, as well as the Office of Research and Development and the Office of Water. And then we've worked a bunch with folks at CEQ, Indian Health Services, Health and Human Services. I would say those are kind of the three main folks that or three main agencies that we've been working with. The collaborators that we had on making that initial national approximation were Internet of Water and Simple Labs. But I think that was an anonymous question, but happy to follow up with, there's more than 200 folks within our list of stakeholders that we've been engaging in this topic. And I would say going forward, the goal is that EPA is actually going to be maintaining this.
So that is the who maintains it, the end part of your statement. Let's sneak in one more question. It said, a great talk. When the authoritative information was incorrect, how was this information received? Did it open a dialogue, resistance, etc.?
Yeah, that's a great question. I would say it depends on who is receiving the information. So when we're talking about tribes or minority communities, it's a red flag of this is not right. This is and I would say there's a bit of resistance and anger and kind of frustration that there continued to be misrepresented in information. Then there's the other half of it with the utilities, which I would say is something that we're still figuring out how to broach. On the local level, at the federal level, there's a commitment to figure out how to get it right. And that's where we've been spending a lot of our time. But I think that the tricky part about this is that they're misrepresenting because it makes them look bad whenever it's inaccurate, right? So like you show a boundary of who you serve, and then if you have a donut on, we actually don't serve the Black community here, then they don't want to have that in a public space. And there may be in the process of changing that, because a lot of the times these water systems were created more than 50 years ago under very different dynamics. So I would say it's a really tricky topic, but ultimately we're having lots of dialogue around it.
And we hope that dialogue continues in the ESIP community. And if anyone has experience working with the type of data that Jesse is describing, we've had extended conversations, and It's really interesting, and I think it touches on so many issues that are in various parts of the ESIP community. So I encourage you to reach out to Jesse over a chat. So thanks so much, Jesse. And next, Shahab, do you want to? Oh, you're on top of it. Look at that. Great. Okay, we can see your slides. And let's see. Okay, they look great, but you're still on mute.
Yeah, I'm unmuted now. Yeah.
Great. Okay, go
Thanks,
for it.
Annie. Yeah, okay. Thanks everyone for coming to our presentation. Today, I'm going to talk about our project on Community Streamflow Evaluation System, or CSES. Our team consists of myself, Shahab Alam, my colleague Ran from the University of Alabama, and Dane from the University of Utah. So, okay. Yeah, so the project was originated from the need for enhanced hydrological forecasting, particularly using the National Water Model. We developed CSES to assess the National Water Model performance as a water supply forecasting tool, particularly for the Great Salt Lake Basin in Utah. As we developed the tool, we realized its potential for CONUS-wide application, which led us to further exploration. So the overall learning objectives are to transition a research-grade product into operations, and how to make the data accessible on the cloud, like Amazon Web Service, because the data downloading was quite slow, and we were interested to explore some key hydroinformatics skills for data sharing. So the technical approach we took was like this. Here I'm showing the CSES GitHub tool for the model developers. I would like to mention that we obtained the long-term streamflow time series from USGS sites for the period 1980 to 2020, so 40 years of data for comparison with the model. Then we extracted key catchment characteristics using the StreamStats metadata. This tool has three classes in the Python notebook. And first one is the state class to determine how the land cover, land use affects the predictive performance of the model. This class takes few inputs like start and end dates, state ID, model ID, and the type of catchment classification. The second one is the HUG class, and it is to grab all the co-located USGS and NHD plus locations within a watershed for spatial model evaluation and aggregated water supply stream flow. The third one is the reach class. Here, the objective or the task is to evaluate the model performance at the selected USGS sites. The key input for this class is the USGS ID, evaluation metric, and start date and end dates. Now I'll show some project outputs. Here I'm showing the output from the state class, but before I go deep into this, I would like to mention that we used National Water Model version 2.1 retrospective simulations to exemplify the methodology of this tool. But our tool is able to take any hydrological model that produces outputs in the NHD plus format. So here I'm showing the Jupyter Notebook interface for the developers. So it shows the application of CSES in the evaluation of model performance with varying land use and land cover changes. These figures show the application of CSIS in the model evaluation for aggregated flows. I mean, the supply-oriented evaluation at different time scales, from daily to annual time scales. Next one is the output from the HUG class to show the spatial variation in the model performance. As you can see on the left in the color-coded map, greener means better performance. More red means model is not doing well in those locations. You can also see the model performance in the table on the top right corner with all the model performance metrics. And you can also interactively evaluate your model using this hydrograph on the bottom right corner. So this one shows the variation in the model performance. But with this, we found one interesting thing is that model performs, the national water model performs well in the headwater catchments than the other places in the basin. And we discovered that these locations where the model is not performing well could be the locations where we have diversions, water control structures, reservoir operations, and so on. So this is very useful in some cases. This is the output from the REACH class. Here I'm showing the daily hydrograph for Provo River in Utah. So it shows that National Water Model is overestimating flows, and it indicates an area where the model needs improvement. This shows the daily accumulated supply for the Columbia River in Washington. Here, the National Water Model provides great estimate of flow for the water supply forecasting. The last one here shows that the peak flow from a storm event on Cahaba River in Alabama is completely missed by the National Water Model, which indicates that we need to improve the runoff representation in the model. This shows the the project output from the Tethys CSIS app for the users. So we put the GitHub tool into the Tethys app, and here is the outlook of the Tethys app. So the users, like the Bureau of Reclamation, river forecasting centers, or public utilities, they can use this app to evaluate the model performance interactively. When the app is ready, it will go somewhere here and be posted on Cairo apps portal. So what we have learned, we learned that CSIS with AWS S3 bucket can provide an easy to use model evaluation tool. And CSIS can CSIS with Tethys can allow users to conduct the model evaluation more interactively and with more flexibility. We learned how to collaborate with other Cairo partners, and we also learned how to transition a research-grade products into an operational tool. Future work, we'll definitely like to mature the Tethys CSIS app with the BYU group. And we would also like to include the Python-based streamflow evaluation tool. We call it SEED, which is under development. We'd also like to include reservoir models, other land cover, land use classes, forcing data. We would also like to include the National Water Model version 3.0, which is currently available. We definitely would try to write a white paper on CSIS application for the next Cairo funding cycle. And last but not the least, we would try to produce a manuscript out of this work. With this, I would like to thank you all and thank you, ISIP, for providing this opportunity to explore so many exciting things. Thanks.
Thanks so much, Shahab. That was great, and as someone that focused on model errors in my dissertation, I appreciate this, how slick this application is to compare observed and modeled stream flows really across the United States. Just one quick question. Where did I mean, you said in headwater catchments, the model performed the best. Any other areas that it did particularly well consistently? Or was it primarily just that places where there are no diversions? Like, were there any regional patterns where it was quite performant or not performant?
Yeah, first we observed this and it struck our mind when we applied this tool to Great Salt Lake Basin, when we were moving from the headwater catchments to the lake area and those built areas and the cities. We are observing that the model performance was declining, and we physically checked and realized that those are the areas where the diversions are happening, and we have those reservoirs and controls on the water flows. So those are, and then we just observe those things in other areas as well. But that was the first time we realized that this is something we are finding consistently.
Great. Thanks so much, Shahab. And if you're a national water model person, which I know there are a few of you here, please engage with Shahab in chat, and just great job overall. Next, we're going to wrap up our lab cohort talks with Liz Ferguson. Liz, could you go ahead and share your screen?
Yep. Okay, how's that?
There we go. Okay, looks
Right.
great.
It's happening. Well, thank you everyone for an opportunity to chat about our project. We are so grateful for ISIP providing us the opportunity through the Lab Awards to be able to look into insect pollinator composition and post-fire recovery of coastal sage scrub, which is a local Southern California habitat. And got to click on this first. And we've got two principal investigators, myself, and I'm actually coming out of underwater environments for this particular project. Because of this, my lovely co-principal investigator, Christina Simicat, who I'm an adjunct professor with Cal State San Marcos with, and she's has the biology and the environmental science kind of background that merges and blends nicely with my more technical kind of background and GIS context. So we came together for this project, and ultimately we wanted to understand how post-fire pollinator networks or the importance behind it is because understanding pollinators is a really important aspect to resource conservation and management, and especially in regions such as Southern California, or really the whole Pacific coastline now, where we're encountering more and more of these wildfires, and it is having an impact and effects in our native habitats, but there's not a vast understanding in terms of pollinators as to how that's influencing them. So the problem really is that San Diego County is a global biodiversity hotspot that faces these increasing fire challenges. And we know through various, literature that pollinators are incredibly vital and important for not only sustaining ecosystem health, but also if you look on the agricultural front, a lot of our food reliance is dependent on these pollinators and robust pollinator networks. There is, however, a need for effective conservation strategies for native habitats to maintain pollinator diversity. I'm sure you've heard in the news that honeybees in particular have had declines. There's been for quite some time now. So being able to maintain a diversity of pollinators, and is an important aspect to really having that plant pollinator interaction persist despite these wildfires and other controversy and issues. So we kind of wanted to be able to incorporate and saw value in this concept of ecosystem services, which is essentially how humans can benefit from the natural environment, and really incorporates spatial information and various models. And for this particular effort, we wanted to focus on a crop pollination model that we found might be useful for having a better understanding of what we would expect within the data. So our inspiration, and I'll get into that in just a minute. Our inspiration is really that there's an intricate web of pollinators and natural ecosystems. And really we wanted to be able to, through this effort and other kind of pollinator efforts, address the gaps in pollinator plant interaction knowledge. There's actually a lot of the methods involve pan traps and other approaches, but what we're kind of interested in is being able to understand that interaction, which doesn't really work well when you use something like pan traps. So it's an important key aspect of our approach. We also wanted to incorporate, and think it's important in this project to incorporate modeling techniques to kind of weigh that against what we're seeing and the data we're collecting in situ. And then understanding using advanced monitoring techniques is another kind of goal of this project. So in terms of our methodology, there's 3 elements to our data collection. One is the use, well, in our methods, one is the use of focal observations, wherein we had trained observers go out and collect information on the groups of insects, so not individual species. I want to highlight that. It's more insect groupings. So honeybees, native wild bees, ants, things along those lines. And also collect information on the interaction of those potential pollinators. We did not actually collect pollen from them in order to and look at where they went, but potential interactions between those pollinators, insect pollinators, and plants. So collect how many times the insect actually made contact with that plant. We also evaluated biodiversity metrics per site. We collected video, which unfortunately did not get incorporated in this project in the way we expected, which I'll touch on later. But concurrently, while focal observations were being collected, we set up wildlife camera traps. And there's a video setting where you can collect continuous videos opposed to just imagery. So we were collecting that along the way. And then also we enlisted the use of Invest, which is a really valuable ecosystem services tool that's accessible and freely available, and the crop pollination model that has been developed by the Invest group. We used that model in order to derive something called a supply index, which is really a relative abundance of the what we parsed out as honeybees and all other pollinators, insect pollinators. And the relative abundance incorporates elements such as land cover type, nesting suitability, and floral resources. And because there's differences in the nesting, in both the nesting kind of resources that a honeybee uses as opposed to some other pollinators, as well as the distances traveled for those honeybees in order to get to floral resources, we decided to separate them out. Our project study area, obviously, we wanted to incorporate fire in a relevant, meaningful manner, but we could not collect data pre-fire and post-fire because it turns out you can't predict where the fire is going to be. Although usually it's everywhere lately. So what we did is we looked at 3 different sites with varying intervals and frequencies of burns. The first site in the northern study area had the most recent burn in 2022, and also frequent burns. I think somewhere along the lines of 8 to 10 burns within the last 10 years. The second site had a most recent burn in 2017, and the last site, which is in the eastern section of the study area, had a burn in 2007. So our expectation is that with varying degrees of, with longer durations of burn, that you would have a more robust and potentially diverse insect pollinator population at those sites. So Invest is again, the tool that we used in order to get at model predictions for the supply or the relative abundance of pollinators at each of those sites. It's also what part of our learning objectives, because we had not used INVEST before. And so we actually underwent learning how to use that crop pollination model and how to modify it for our purposes, as it's originally intended for looking at wild bees versus, I guess, managed bees. So just to touch a little bit on our results, there's more in our slides as well for our poster, as well as a short video that we put together. But in this particular slide, you can see on the left-hand side are our model results. And the first site there has basically the site with the greater burn interval and the most recent fire. There was still a prediction by the model that there would be a greater supply or greater abundance of honeybees, as well as the green all other pollinators at that site as compared to the other two sites. However, the actual anticipated distribution of bees in the yellow versus all other pollinators in the green was predicted to be kind of within the model to be similar at each of those sites. What we saw over on the in situ side and the in situ observations was that that first site with the greater, more recent fire interval had a greater diversity in pollinators and a much lower occurrence of honeybees as compared to that second site. And we saw more of an even distribution between all pollinators and bees at the third site, which had the longest duration sense of fire. So we saw something a little bit different. And in evaluating this and looking into it a little bit more, and we kind of specify this in terms of our research outputs, our thought is that there's potentially something going on in terms of reservoir habitat, which is that I should go to this last one, sorry. At this first site, there's a greater volume of natural, contiguous natural habitat, that's coastal sage scrub surrounding the actual site where we collected our observations, as compared to this Fairview and Palamesa, which had obviously longer duration sense of fire, but also was quite fragmented and didn't have that consistent coastal sage scrub that occurred at this Rock Mountain site. So our thought is that potentially that reservoir habitat allows for the quicker recovery of those pollinators as compared to the other sites, is an important aspect of what our findings were. So we detailed this in our GitHub site and in a report. We included the data sets and analyses generated through the INVEST pollination model, and that's all available at our GitHub repository, which we welcome you to delve into a lovely long report if you're interested in looking more at the diversity results and whatnot. One other research and outreach collaboration kind of discussion point is we also put together an ArcGIS online dashboard that allows for individuals to explore our project a little more interactive methodology. And there's a short video in the video repository that runs through this, so I won't touch on everything, but it gives you a little bit way of being able to interact a little bit more with our data. And we're super excited about this particular project kind of deliverable, because I don't know, dashboards are amazing. The other thing that's a potential collaborative opportunity is we were able to collect data, but from video, but as I mentioned, we weren't able to incorporate in this particular project. We did have a camera that was stolen at one of the sites, fortunately. We also had some pretty significant data management issues. We were originally using some custom-built Raspberry Pi based cameras, and obviously due to supply chain issues, the cost of that and the availability of that kind of precluded us from using it. So we moved to these cameras just before this project and had to deal with some significant data management issues, which we've actually been able to get through. So that's helpful. So we're at the stage now where we also had some turnover in terms of our analysts. And what we're doing with this video, and I'll just play it while I'm talking, is we're taking this video and we're developing deep neural networks in order by tracking, annotating data by tracking the bees. So we're using Dive and VMA in order to annotate and then develop deep neural networks for being able to track those insect pollinators, so we can have a bit quicker way of getting through this video as there's so much of it now, and we have trained analysts and we're ready to go, but we're new to the deep neural network in terms of use in video. So obviously a good opportunity there. So key takeaway is that large contiguous habitat reservoirs, provide resources for diversity in pollinators that are impacted by development, fire, and invasive species. And again, thank you all so much for the opportunity, and I hopefully did not go over too much there.
Thanks, Liz. Great work. And I think maybe we can, there's some exciting things happening in chat relative to bee conversations. There's clearly some bee enthusiasts, and thanks to everyone who is providing that commentary. So with that, we have just enough time to have all of our speakers join for a little bit of a panel discussion. So thank you, Patty, for highlighting or spotlighting the full team. So I wanted to pose a question to all of you, and this is one that I kind of pre-posed over Slack to this team to hopefully get some folks thinking. But as you all have showed, you've created these, amazing applications over a variety of wildfire and water issues. And I really see you as some prime data users in this bunch, that ESIP is a community of data professionals and data users. And I think you might provide some particular insight to our to those in this crowd that are supplying data. So my question is, what do you wish data providers would do to make their data more accessible? Or what do you love that they're already doing? And maybe just give a brief answer, but if anyone wants to hop off mute. So again, what do you wish data providers would do, or what do you love that they're already doing? And I will just call on the first person who I see unmute.
I can kick it off. It's a really easy one, but unique identifiers have the same unique, like a system of unique identifiers across all different data sets that you're rolling up into a national one. We found that that was not always used, and made it very, very hard to link between different data sets.
Thanks, Jesse. One for unique identifiers. Anyone else? Raphael?
Thanks, Andy. Yeah, I mean, I absolutely love all the public data is out there. It's great. I guess one thing I'd hope is that sometimes these public data are still slightly restricted by like some sort of login or something, which makes access with some tools really difficult. So hopefully see kind of totally open public data.
Open data. I love it. All right, Mike, I saw you come off mute.
Yeah, I was going to mention issues of authentication too, following up on that, but then also I think there's a lot of unique tricks that people can do to change data standards to meet a certain application, but then if it's not documented, trying to use that as someone else, like your dimension order and netcdf files or things like that, can be a bit tricky too. So either well documenting changes that are made or following conventions a little more closely can save a lot of hurdles. And I'll call out NOAA in particular on this one. Most of our images, if you pull them down from the S3 buckets, are flipped. We'll have Florida up in the Pacific Northwest and Oregon down in Florida, just because it's packed a slightly different way. But if you don't know that and you're pulling out just a subset of Colorado, it's going to look like it should, but be inverted.
All right. Thanks, Mike. Anyone else have a Shahab?
Yeah, so I was attending one presentation from Dan Ames from BYU. He was saying that no more netcdf data, because this is something we cannot deal with anymore when we talk about the continental scale. So recently I personally realized that downloading the netcdf data, the big files, and dealing with that is huge task. and this is a big hurdle. So if the data is in Parquet or Kerchung format or something like that, I'm not a data scientist, but I know there are some formats that will help us to overcome these hurdles quite effectively.
Thanks, Shahab. And I hope that the NetCDF enthusiasts in the crowd can engage with Shahab in chat or find him throughout the session to continue that conversation. Before I move on to the next question, Sonia or Liz, anything relative to that question of things that you love data providers are doing or things that you wish that they did?
Not stepping on it. Yeah, I mean, to be honest, I think our project kind of highlights the fact that, you know, these institutions are now making accessible models and methodology that anybody can really leverage and use if you have enough of a GIS background is kind of necessary for this particular project. But I mean, just more of that would be awesome, and I think more kind of synthesis across those. Like, it'd be great to see a crop something like this, but integrating fire, because it is such a critical, you know, and spatially available kind of data source. So it'd be nice to see a little bit more integration.
Great. Thanks, Liz. So more and better integration. That sounds great.
More.
And Sonia, oh yeah, Sonia, you don't have to ask a question if you don't want, or I could skip to the next one. What do you think?
Well, I was just going to add that the automated surface observing system, which is where we got the weather data, overall was really great. The University of Iowa has a very nice like click and download to get the data. An API would be awesome, but that was overall pleasant. And then, I mean, if certainly, like, we had to archive Surfline, and for the Department of Transportation cameras, we will also have to archive it ourselves, which makes sense because we're kind of taking their data for our own use. But like a historical repository of images would be great too, or just like, I don't know, the past week of data.
Great. Thanks so much, Sonia. So with our 5 minutes remaining, and again, I think there are probably some folks that are interested in Sonia's comment as well relative to data access APIs and repositories. But I wanted to end with a question to this group about what do you see as the greatest opportunity for new knowledge related to water and wildfire in the United States? Are there any new data streams or tools that you think will be providing us insights in the future? Shahab?
Yeah, I'll go first. And so as I'm working with the National Water Model, the NOAA has developed the next generation water resources modeling framework for the whole country, and also they're extending it they have already extended it to Alaska, Puerto Rico, Hawaii, and those islands. So it has extended from only 4,000 observation locations. So we used to have the flood warning and like other weather information at about 4,000 locations, but it has extended to about 2.7 million river reaches over the continent and over the country. So it has potential of becoming a source of great information for forecasting and water resources management. And so the project Cairo is mandated to take it to the next step, make it operational through a lot of research. And so it has a lot of opportunities for the researchers to contribute and make it a national scale usable source of information for flood, drought, and weather-related forecasting. Yeah.
Thanks, Shahab. And maybe we have time for one more. And then if everyone else wants to drop theirs in chat, does anyone want to kind of have the last, where do you see the frontiers in water and wildfire? No one's like, I do not want to have the last word on this, but Jesse, I'm going to give you the last word since you unmuted. Go for it.
Well, I spent all the time talking about where you get your drinking water from. And so we said there's 50,000 different drinking water systems, but the other side of that is wastewater systems and flooding, or wastewater systems and stormwater systems. And there's 15,000 of those, and we have no clue where the wastewater and stormwater collection systems are. So I'm really excited for that. We've had a couple of preliminary conversations about how we can do so. So then we have like the full understanding of who is serving and how do you improve water infrastructure across the board.
Thanks, Jesse. Let's end with a note on wastewater. I love it. I'll say a big applause to all of our lab speakers and on your efforts over the last several months. And the rest of the ESIP community, please do engage with these folks. And if you have any questions about their projects, what they're doing with their data, how they're making their projects fair, thank you, Pierre, for your comment in chat. You can reach out to me, lab@esipfed.org, and I can get you in touch. And with that, I'm going to turn it over to Allison to take us into, or tell us a bit about our afternoon coffee break. Allison?
Hey everyone. So we've got kind of a fun coffee break this afternoon. So we've got two more sessions, and then I am going to be leading a little hands-on movement and digital art drawing session. So if you feel like you need a little bit of a break, art is not mutually exclusive with data and logic and all of the rational thinking that we've been doing. And it can be a nice little refresh. So hopefully we'll see you this afternoon, or we will see you in the sessions. Thanks, everyone.